right, guys, so what we're going to be looking at today are just different things with the graphing calculator so that you're kind of familiar with using them tomorrow with the ACT, as well as some of the stuff we've gone over before, just re-going over it again. Because there are some functions that we haven't used in quite a while. So I just picked out a few things in general that we'll look at and then go from there. Now, one of the first things that we can talk about or look at is plugging values in. So there are going to be some functions or some problems that it asks us just to plug them in. That's it. Now we can look at the first one. Given f is equal to cd cubed, f is 450, d is 10, what's the value of c? Well, so we know c times 10 to the third. Now we could set this up and then solve for c. So we have 450 is equal to c times 10 to the third. Divide both sides by 10 to the third, and that would give us c by itself. So 450 over 10 to the third, 925 or 0.45. So the answer is F. Now another way we could have gone about it is just saying, well, yeah, so 450 divided by 10 to the third. Now we could just gone and picked a value for C, so 15. 15 times 10 to the third. So we can pick either calculator. So you did 450 over, so 450, y equals 10 to the third. Let's see. Because it's thinking, so hit enter. Enter. Because since it has that spot, it's looking for an exponent in that location. So we get this here. Now we can say, so we get 9 over 20, 9 divided by 20, 0.45, same thing. Now we could have gone the other direction and just picking a value for C and tried it from there. So I just picked 15 because the middle value is 15. Well, that didn't work, which means since it's too big, the others that are bigger aren't going to work. Then I can say 4.5. I can say 4.5 times 10 to the third, which is closer. Well, let's make sure, put another parenthesis. Yeah, if we do 0.45 times 10 to the third, we do indeed get 450, what we wanted. So a lot of what I consider plugging in values are just plugging them in. Plugging them in, try and see if they work. The same thing is true of number 5. F of x is equal to 3x plus 7 squared. Find f of 1. We're just replacing x with 1. And on these here, we can use the 30xs. We can say 3 times 1 plus 7 squared. And we see that it is 100. We can do in the graphing calculator, I can say 3 times 1 plus 7 squared. And we get 100. Now what's interesting is we could graph it, parentheses 3x plus 7, close parentheses squared, and hit graph, and we get this graph. Now, second table. The table is just a list of the x and y values. When I plug an x value in, the y value is what we get out. So I can look when x is 1, the y value is 100. And the table on the graphing calculator works very nice, especially if the x values what we're plugging in are nice numbers, or 1, 2. We don't have a decimal. Now, one thing we can do is second trace, and the first one is value. And I could select this and say -7 thirds, -7 divided by 3. and it'll tell me what the output, the y value is. And in this case, it is 0. I mean, I could do this for any value. Second trace calculate. Say the square root of 2. Tell me what the output value is. It can do it for any and all values. So especially if we're given a function and we're wanting to find its value, it can be very helpful. An actual example of that is 27. What are the solutions for x if 3x squared minus 2x minus 21 is 0? Well, in the graphing calculator, we can say I got it. 3x squared minus 2x, and then I think it's minus 21, yes? Graph. So we're trying to see where it crosses the x-axis, what values of x are going to make it be 0. Now, one way I can go about this is looking at our possible solutions and just taking one and checking it. So we can say negative 21. I can say second trace value, negative 21. Huh? That's one of the answer choices, yes. Or we could say 3. Well, when x is 3, the y value is 0, yes? So that tells us 3 is one of the solutions. Well,
wait, how do you see this? How do you type it in when it's on the graph? How do you...
Second, calculate value. So that lets us type a value in, so we can check to see if they work. Now, negative 21 was throwing a little bit of a fit about it, mainly because the value for it was outside of the x range, negative 10 to 10. But since negative 21 is a quote-unquote kind of nice number, it doesn't have a decimal, we could just use the table, scroll up or down to negative 21, and see, is it a whole number or not? If it is a whole number, then it works. If it's not, if it's something other than 0, then we have to do a little bit more to it. Okay. Now at 3, we do see that we get a value of 0, which is what we wanted. So if we look at all of our answer choices, any of them that do not have a solution of x equals 3 don't work. So A, E would not. So the last two that we have are negative 7 and negative 7/3. Well, we can try negative 7. I can say second trace value, negative 7. Do we get a y value of 0? No. So we can try negative 7 divided by 3, negative 7/3. Do we get a y value of 0? So the correct answer is B. So we didn't have to actually solve it. We didn't have to use the quadratic formula. We just let the calculator do the work for us. Now, 18 does show up on the ACT from now and then, ordering numbers. Now, trying to see and determine which one's going to be biggest or smallest between 1/2, 5/6, and 5/8 may not always be the easiest, but we can turn them all to decimals. Because 1/2 is 0.5. 5/6 is going to be 0.83 repeated, if I remember correctly. And 5/8 is divided by 8. 0.625. So we can convert them all to decimals and then arrange them in ascending order. Now, say we didn't know what ascending order was, but we do know that we're either going to go from biggest to smallest or smallest to biggest. It's going to be one or the other. So which one is the smallest? 0.5. The biggest is 5/6, yes? So no matter what we do, 1/2 and 5/6 need to be on the ends, one way or the other. So F, 1/2 and 5/6 are indeed on the ends, yes? How about G? No, can't be G. H, yes. J, K. So even if I didn't know or kind of wasn't sure of what ascending order was, just ruled 3 out of the 5 out. I have a 50-50 shot. I have a 1 in 2 chance of actually just guessing and getting it right. But if we look at ascending, to ascend means to go up, yes? Because we can ascend a flight of stairs. So it should be F. They should be getting bigger. Because if we descend, it's going down. Decreasing order. So if you can eliminate answer choices, it's always a good thing to do. The last one on this first part is this one here. Now, here we go. I was looking for a copy of this here. What we can do with this here, if it has square roots, I would use the yellow calculator. So we have 4/2 square root of 2 plus 2/2 square root of 3. And we get this here. Does this match up with any of our answer choices? No. And if we look, actually all of them have a radical in the bottom of the fraction. Because if it was nice we didn't have radicals in the bottom of the fraction, we could just match it up and we're done. But now we just need to see which one of these actually lines up, which one of these is going to be the same. And to do that, we can just start from the top and plug them in, or we can turn this into a decimal. So I turned it into a decimal, used our 2 arrows. We get 3.98312. 3.98312. 7663. So what we could do here is just write the decimal or the actual equations statement there. And then I can just start plugging these into the calculator. So I can start with the first one. 4/2 square root of 3 plus 2/2 square root 2 all over square root of 5. We get this here. Is this the same as our decimal that we got before? No. So we can go to the next one. 4/2 square root 3 plus 2/2 square root 2 all over square root of 6. It's the same thing, so the answer is G. If you noticed, when we plugged G in, it gave us the same type rational expression of what we had from the get-go. Yeah, but again, we can see decimals a lot easier than we can see radicals. So even if we don't get something as nice as that, if it's asking us to just simplify radicals or cubics or quartics, any of our radicals that we've been dealing with in class tells us simplified as pure numbers, and it doesn't simplify nicely, convert them to decimals and see which one's the same. And then go from there. Kind of most of this makes sense so far, but most of this is trying to get y'all back used to using the graphing calculator. And again, if you don't feel comfortable with it, just stick with the 30XS, the yellow calculators. What is the product of two complex numbers? With this here, with product, addition, subtraction, plug it in as you see it. So the product of two complex numbers.
It's second and the dot at the bottom.
So if we multiply these, so we can grab the graphing calculator, parentheses, -3, second dot, plus 4, times 3 second dot, plus 4. 25. They kind of wrote it in a different way than we're used to seeing. But if we notice the signs in front of the eyes are different, everything else is the same. This is our difference of perfect squares. Our complex conjugates. So it is 25. And that's it. We could do the same thing with addition, subtraction. It doesn't matter because the other one, 2 minus 2i minus 4 minus I is 2 minus I. We could have said 4 times 2 plus 3 I to the 4th minus 3 5 I to the 7th plus 25 and squared. I just made something up on the spot with this here. But again, no matter what it is, addition, subtraction, multiplication, powers, it'll do it for us. Now, if we look at 48, they gave us this half just to say that this is how we would solve it. We would multiply top and bottom by 1 plus I. But really what we're looking at is this division here, 2 over 1 minus I. Now, in the graphing calculator, we can try 2 over 1 minus I. And this one here does give us 1 plus I. However, the 30x, or not the 30xs, the TI-84 plus, not the CE, but just the plus, gives you an error. It doesn't like it. 4 plus. So the black one, y equals enter 2 over, let's see here, because it was 1 minus I, yes? Gives you an error. And as much as I like that one, I kind of like this one. Looks a little bit nicer. What we have to do is something a little different. We'd have to rewrite it as numerator in parentheses divided by the denominator in parentheses. Put the top in parentheses divided by the bottom in parentheses of the calculator.
Oh.
Yep. And we'll get this here. Now this one's nice. It's 1 plus I. As a single term. And that's it. That's all we'd have to do. Now, I'm going to change it just a little bit. So if we said, I'll end up erasing the whole thing, minus 3I, 2 minus 3I. Okay, might as well just restart. 2 minus 3I, in parentheses, divided by 4 plus 5I. We get this here. We get these decimals. Now, if y'all remember how to fix decimals, if we go math, enter, enter, math, enter, enter, math, the first one's fractions. It gives us the answer. So if it gives us decimal answers, we can go math, enter, enter to get from decimal to fraction. Questions on any of this here? Now, one of the things to pay attention to is if we said this here, square root of negative 9. We've done this a few times by now. We know the square root of negative 9 is what? Well, square root of 9 is 3. And if it's negative, the negative comes out as I, yes?
Oh, yeah.
So the square root of negative 9 is 3. I. Non-real answers. So the calculator, if you notice up at the very top, it says real. It's sticking in mainly real answers. It's only going to work with real answers. Now to fix that, we have to say mode. And if you look halfway down where we have a plus bi, we have to turn that on. Second quit. Now if I do it, mode, if you click mode, and you'll see about halfway down it says a plus bi.
What?
So you clicked mode, about halfway down it says a plus bi. You got to scroll all the way down to it and select over, move over and select a plus bi, and then you can do second quit. Once you've got that turned on, you're good to go. Now, you don't need it for adding, subtracting, multiplying with I. You only need it if you're taking the square root of a negative number. Only time you'll need it. Questions on any of those here? The next nice thing that we can look at is matrices. Matrices, yes. This is one of, once we saw how to do these in a calculator, I think most all of y'all did like doing these because it was just plugging them in. Huh? Second, matrix. Second, matrix. Now we can go over to edit to plug a matrix in. Now we can do the first one, number 1, negative 4 times 5, 1, 6, 0. Now it is a 2 by 2. So we have 5, 1, 6, 0. And we can type the 2 by 2 in, rows by columns. Second quit. Now that we have the matrix typed in, we can say negative 4, second matrix A. And then hit enter. It'll give us our matrix. Now I will tell you this here, if we do scalar multiplication, just like this here, we're multiplying a number by the whole matrix, the size of the matrix is not going to change. It's not going to go from a 2 by 2 to a 3 by 3 or 1 by 1. The size of the matrix is not going to just sporadically change. For us to be able to add or subtract two matrices, they have to be the exact same dimensions. All of them have to be the exact same. So with the 3 by 3s here, we can bring up the graphing calculator, go second matrix, over to edit, say 3 by 3. And then we can type it in, negative 4, negative 5, 5, 1, 6, 3, negative 2, 2, 1. Second quit. Second matrix, we can go over to edit. Matrix B is a 3 by 3. Negative 6, negative 1, negative 6, 6, negative 3, negative 2, 4, negative 1, negative 3. Second quit. And to subtract them, we just recall matrix A minus matrix B. We get our answer. And it really doesn't matter how we type it in. We can do whatever we want with it. We can say 4/13, second matrix A, plus 6/19, second matrix B. I can guarantee you these numbers are not going to be nice. But it does give it to them. it does give us these values. Now, if for some reason it gave us decimals, I'm going to try to see if I can get us to get decimals. Okay, well, apparently it's be quite sturdy, yes, times. I'm kind of impressed that it's still giving us decimals. You know what, let's do 9. Okay. If it did give us decimals, we can just do math, enter, enter, tell it to turn it back into fractions. Because for some reason it is sticking to decimals and our fractions, and I am perfectly fine with that. Because most of the time, especially on the ACT, they're going to give you fractions over decimals every single time. Because decimals, most likely, unless they work out nicely, are going to be approximations. They do not like approximations. On the ACT, the correct answer is the correct answer. There is no ambiguity in it. Does that make sense? And what I mean by that is and you've come across this at some point in your high school, middle school time when you've taken tests, that A and B, if multiple choice A and B or A and C could be both correct, but in a certain situation, A is more correct than C, so you pick A. Or in another situation, C is more correct than A, even though they're both correct, so it's C. Did you all have seen that before, where two are close? ACT, the correct answer is the correct answer. There is no arguability. You can't argue one or the other. Does that make sense? So that is the nice thing. So if, especially on the English, I will say this for the English section, if you do come to one where 3 of the choices, because it's normally you get 3 choices and no change, if the other 3 are saying the exact same thing, it's most likely going to be no change. Because I always lose track of the third one. It says comma and, semicolon. I can't remember what the third one, but those are just the same conjunction, combining 2 sentences. If you end up getting those 3, it's no change. Neither one of them saying anything different. And the last one is, here's determinant. And I think we feel comfortable, y'all feel comfortable with plugging these in. Now to get the determinant, we can go second matrix over 1. The first one, DET, is the determinant. Second matrix, I'm just going to take A from the one we used earlier, not the one that we have there. But matrix A, the first part of problem 4, is 105. If we use the one on the paper, it'd be 39. If we did for this one here, it's 39. A determinant has to be a square matrix, and it's going to give us a single number. Now we could also find inverses, because if the problem asks you to find the inverse of the matrix, well, I can recall the matrix here and hit the same button we use for the matrix to pull it up, x to the negative 1 after it, and it'll give us the inverse. Now here, math, enter, we can convert it back to fractions, and this would be the inverse of the one we put in for A. We get this here. Now that does leave us with the first one. What is the matrix product of these two here? Yes? Now, unfortunately, the first one does have variables, yes? But it is a 3 by 1. Now I'm going to just plug the numbers in without the variables, because again, this calculator needs a value for x. It has to have a value for x, so let's just leave it as 235. Second matrix. Matrix B is a 1 by 3. 1, 0, negative 1. Second matrix, so back over at math, we do have a whole list of items. Because we have DIM, all these here. Now, one of them we ended up I realize I didn't include on this here, but probably should have, is RREF when we're solving systems. If you all remember doing this here, because we took the coefficients, the numbers in front of the variables, and wrote it as a matrix, x, y, z, what it's equal to. Wrote it out and then did RREF. If we have time, I can try to make something up for to work for that there. Now, DIM, I kind of made fun of this function earlier, and it is kind of silly, because what this is dimensions. Dimensions of matrix A is A. Well, I should know that. I put it in as a 3x1, yes? But one thing that is kind of nice, especially with, say, second matrix A, second matrix B, if I multiply the two together. Because if we don't remember our properties of multiplication with our matrices, I can do this here, and it tells me it's a 3x3. Okay, well, that might be helpful. Because if I look at my answer choices, which ones aren't a 3x3? Yeah, so it's A. And what's interesting, even though I don't have the variables, delete that. I do get that there. It's just adding x with those. But that's it. Now, to take an inverse, it has to be square. To take a determinant, it has to be square. Rows and columns have to be the same. With addition and subtraction, we have to have the same dimensions for both. All the dimensions have to be the exact same, otherwise we can't add or subtract. Does this make sense? Why don't we go on and do a system? I have no idea how. So if we wanted to do this as a, solve this by a matrix, the first thing we'll do is grab all the numbers and put it in a matrix. And then we would use the RREF to solve it from here. 4, -3, 7, 15. And we'll type them in. And we want to keep all of the x first, y second, z third. 4, 3, 72. 4, 3, 72. 6, -5, 14, or 16. 6, -5, 13, it was a -16 thing. So we get this here. Second matrix over to math, we would pick RREF. Second matrix A. Enter. I am not surprised. Now I could do math, enter, enter, and those would be our solutions. Now, yes, they're ugly, or not ugly, but they're just not nice numbers. I expected that because, well, the numbers that I picked for this here were not all that great. Let's just try 17. Well, sure. I don't think that's going to make it any better. Nope. Really almost didn't change a thing. Oh. That's why. Yeah. Gives all denominator 19, but it's still not nice numbers. if you have to do these on the test, the numbers that you will get will be a lot nicer than what I just did, because I just pulled these numbers out of thin air. Okay, the last thing we're looking at is some of the solving type questions. Now, if we look at the first one, example 7, odds are, when I say odds are, I mean 100%, because I don't think we have not dealt with natural logs, ln, at all in this class. We have not done that. Now, what we can do with this here is I can graph it. For the first one, we can put ln of x minus 4 in the first one. And the second, I can say ln of x plus 6 minus ln of x. Right next to 4. And once I type it in, I can hit graph. Now, we do get these funky looking graphs, but we're looking for where the two functions are equal, where they're the same, where they cross. If you go second trace, number 5 is intersection, where they cross, where they intersect, where they overlap. Enter. Now, to do this, if you notice the y value doesn't exist, it doesn't show up, you're going to have to hit left or right. Now, if you notice all the graphs are to the right, I'm going to hit the right arrow. If they were all to the left, I would hit the left arrow. And I'm just really trying to do this so the x shows back up. So we have an x and y. Most of the functions, if you do this, should have an x and a y to begin with. Y value showing up, x values. We'll hit enter. The second curve, we see that we do have an x, we have a y. Enter one more time. It tells me the intersection is at x equals 6. I didn't have to know a thing about natural logs. The calculator helped me out and did it for me. The other option is to get this thing equal to 0. Now, to do that, well, ln of x plus 6. Well, whatever ln of x plus 6 is, if I subtract it from it, it's going to cancel out. Tell me I have ln of x minus 4 minus ln of plus 6 is equal to negative ln of x. All I did was make it one function, get it equal to 0. Addition, subtraction, just moving everything to the same side. So in the graphing calculator, minus ln of x plus 6 plus ln of x. Need to get rid of that extra x. Clear it. Graph. Because now we got it equal to 0, so wherever it crosses the x-axis is going to be the solution. We see when x is 6, the y value is 0. We have the solution. We're done. And again, unlike this here, the ACT will have, for some of these problems like this here, they will have solutions for us. So we can plug them in. So looking at this here, x cubed minus 3x squared minus 2x plus 6. Clear. X to the third minus 3x squared minus 2x plus 6. Well, how many solutions should we have for this here? 3. Higher degree polynomial functions, the number of solutions is equal to the degree. Biggest exponent is 3, so we should have 3. Graph. How many times does it cross the x-axis? 3 times, yes. And we can look at the solutions that they give us. Well, one of them's nice. One of the solutions is 3, yes? So I could go through like we did on the first one. Any one of the answers that does not tell me x is 3 is not correct. And then we can look at some of the others. So I can look and see which ones have x equals 3 and have 2 other solutions. Well, we could say square root of 2. Does give us y value of 0. We can go from there. So hold on just 1 second. There's a few other things I do want to say. I'm not so much worried about this one here, but I will say for, I think, most all of y'all, hitting a 19 or 20 should be your goal, getting at least that. Because if you get a 19 or 20 on the math and English part of the ACT, and you want to go to college, that will prevent you from taking a 0 level course, which is a remedial course, which you have to take the actual math or English classes. It still costs money, but it's really not helping you with credit-wise. So getting those, 19 or 20. So hold on. But to get that, you need to get a 50%. So you need to get half of them. And they say the best way to do that is to focus on questions 1 through 30. Now, I wouldn't say this for the normal written test, because filling in if you run out of time in the last minutes is not hard. I think some of y'all, or you figured out last time, trying to get through a ton of questions really quick with the online one is not easy because the computers are slow. I would say, especially if your goal is a 19 or 20, as soon as you start the math, go straight to question 31. Fill in 31 through 60. If you know it and it pops up, you're like, oh, I know how to do this. Go on and do it, fill it in, answer it, but get those in. Go back to 1 and go from there. If you do get back to 31, just keep going through it. That way you're not rushing at the end to fill it all in.